Hey folks, welcome to Advent of Code in F#. I took an early start this morning and the puzzle has just unlocked, so let's go and take a look. Day 7, no space left on device. Oh, that's a message I get often. Okay, pretty big text, hey, that's fun. Looks like my command line. Cool. I'm gonna grab my input before I start reading. It's a little over 1,000 lines. Let's see what the puzzle has in store for us today. You can hear birds chirping and raindrops hitting leaves as the expedition proceeds. Occasionally, you can even hear much louder sounds in the distance. How big do the animals get out here anyway? The device the elves gave you has problems with more than just its communication system. You try to run a system update. Pretty pleased with sugar on top. That's also how I do it, my package upgrades. Okay, but we have no space left on the device. Perhaps we can delete some files to make space for the update. You browse around the file system to assess the situation and save the resulting terminal output, which is our input. Okay, so we change directory, we list contents, change directories a bit more. I don't know what the dir thing means. Let's go take a look. The file system consists of a tree of files and directories, sure. The outermost directory is called /. You can navigate around the file system, moving into or out of directories and listing the contents of the directories you're currently in. Alright, that's clear. We finally start to have like some different commands. Within the output, lines that begin with a $sign are commands you executed, very much like some modern computers. Okay, so those are the actual commands and everything that follows is output. Clear? CD means change directory. Oh, yes. Specific result depends on the argument. Yeah, so you can move down or you can move in and you can move out. That's clear. CD / drops back to the root folder, sure. ls means list, prints out all files and directories immediately contained by the current directory. So we have file ABC of size 123. Okay, and the dir prefix means it's a directory. Okay, that's clear. And if we have this, is it just going over every directory? Will it go into A and D? Let me take a look here. Yeah, we go into A, go into D. Yeah, looks like a depth first search, something like that. Okay, but this is the entire directory structure with all the files. Cool, makes sense. Since the disk is full, your first step should probably be to find directories that are good candidates for deletion. Find directories, okay. Total size of each directory needs to be determined. Sum of the sizes of the files and directly and indirectly, so it's recursive over subdirectories. This sounds like a really fun problem. In real life, I would just use Windows stat. I work on Windows machines a lot, and it's a handy tool to aggregate directory sizes and look where your main offenders are if you need some extra disk space. But anyway, we're digressing. So we need to calculate directory sizes, or rather the size of the root directory. Sum of every file. A directory by itself takes no storage, it's just the files in there. That's clear. To begin, find all of the directories with a total size of at most 100,000, then calculate the sum of their total sizes. Okay, so we don't need to do a... Wait, let's go over that again. I don't understand what they mean with directories with a total size. How does that happen? Or how do I interpret this with the recursive nature? So this is the size of a directory with a single file. Makes sense. Then we have another directory that contains files and another file indirectly. Okay, so it makes sense if we just get all the directories and then recursively list all files and then sum up. I don't know. We can leverage the tree structure. So yeah, we just need to loop over every directory once we have the sizes. Okay, sounds like a very fun puzzle. Let me grab the example. It's somewhat of a bigger, not somewhat, it's a bigger, this year's biggest, I think, the puzzle, I mean. So we'll probably be here for a while. But yeah, sounds like fun. Let's take a look. So we have commands with a dollar prefix, and then we have output that is no dollar prefix. And we need to link results. What do we actually need to do? How do we build this tree structure ourselves? Do we need to actually parse the commands? Can we just loop over all the outputs? Yeah, it does not print the current directory. So we at least need to grab this thing so we know in what context we're printing out the contents. Sorry. Is that true? An ls command, we don't know where we're at. So we need to keep track of the current directory, yes. Yeah, let's keep track of the current directory and let's... or now I'm already thinking about how to run or execute these commands. Let's maybe first parse these commands. That's a better first step. Okay. So let's introduce some types. Line we parse is a command or some output. Let's call it that. And a command is change directory or list current directory. That's it. Yeah. Output is directory or a file, and directory has a name and a file has a size. Will we get there by sticking to ints? Perhaps, perhaps not. Let's go long, just to be sure. So a file has a length. What's a long again? int64? It's just 64-bit signed integers. That's a long. Has enough space for us, and we have a file name. My formatter keeps duplicating. I've not yet fixed this, and I keep complaining about it. But there we go. So we have commands, we have outputs, and we have lines, which are one of those two. Let's parse. And let's write a parse function here. There we go. What's the first thing we need to do? Distinguish between commands and output. That's the first thing we need to do. So let's explicitly type line so we can do string stuff on it. If it starts with a... Oh, I think partial active patterns. That's something I don't use often. I think it's a good match for this problem. Whenever there's parsing and there's different things you can parse into, if you have a pattern match, basically. Yeah, let's go. It's been a while since I've used them, so I'm going to grab the docs. Partial active patterns. These are the official. Should I grab the for fun and profit one? Yeah. Scott has done much for the F# community. His documentation or his website is amazing. But yeah, this is the principle of an active pattern. You can create cases of multiple types. Actually, you can create cases you can use in pattern matching, but you can. It's an open-ended list. It's not like exhaustive like an enum or a union type. You can just write these 4 lines of code and you have the int case to match on. And then if you write a bit lower a bool construct like this, you can pattern match on bool and then you can use it in pattern matching like this. So I think that's a neat approach to, for example, parse into commands and output what we are doing. So let's try that. Let's play around with active patterns. So if it is a command, I'm thinking the pattern match will do the actual parsing, right? I think we can do that. So let's write an active pattern. What was the syntax again? Oh yeah, so it's the banana clips. I think they're called banana clips because they have like these parentheses and this pipe. Looks like a banana. And you can take arguments. You have to take arguments, or you don't have. Yeah, you have to. How do you return options? Line is a string. Let's also type that here. So if line starts with this was what we were this was what we were trying to do. Oh, you know what? We're gonna keep it simple. So match line with I'm thinking, what's the easiest way? No, never mind. Let's go back. Go back some more then. Let's just... There's a better way to do this, I am sure, but if we just skip 0, 1, if we just skip 2, we have the rest of the string, which is cd. Oh yeah, cd takes an argument, of course. NLS. So here we're matching with line substring, and if it's cd followed by something, You know what? I'm gonna not work on strings, I'm gonna work on sequence of characters. So the first character in the string is $, then it's a command. And then we're gonna match line skip 1, 2, skip the first 2, that's a space and a $. And now we can pattern match on the list. So that should be a C and a D. Followed by... Can I pattern match using the... Yeah, I think we can pattern match. That's a lot of parentheses and piping. Let's see if there we go. Can I not pattern match using the concat operator? No, appears like we can't. I think I've seen that before, but we can pattern match on the cols operator or this thing. There we go. What's it not liking? Let's see. Let's get it to compile first, because there's a lot of red and I don't know what's happening. So yes, yes, yes. We're returning an option. Expression expected to have type unit. Oh, there's an if. Yeah, yeah. I don't think we need to. Yeah, we can keep it in a single match. Let's keep it in a single match without the if surrounding it. So now the if can go, and it's simple single pattern match, or simple. We're doing a character by character pattern match, so that's a bit weird, but there we go. How is command not a... Oh yeah, it's the type, so we can get rid of it. There we go. Took some time. Yeah, now all we need is to parse out the directory. Is it always a single character? Not that it matters that much, but... No. We have these directories. Those are fully fledged strings, so let's keep those strings. So that is the... That's the directory, and let's put that back into a string. Why not? Does that work, or do we have to convert to strings first? We have to convert to strings first. Oh god. I'm not sure if I like my pattern matching character by character thing anymore. But I think we are parsing commands. Let's try this. So let's see if we can parse a cd command. So let's try to parse one of the examples, cde. Why not? And I'm gonna make it harder by having more than one letter in the directory name. Match cases were incomplete. Interesting. Oh yeah, there's a space. No, that's not a problem. But that's a bug waiting to happen. There's a space trailing the cd keyword. Interesting. Why is this not working? Oh, we're skipping that. We don't need to skip anymore, right? We are pattern matching on the entire line. There we go. Hopefully this has more effects. It has more effects. We are parsing change directory commands. Cool. What's the other command? ls. What is actually the official... What does ls mean? List information about the files. But why the L and the S? Digressing. I don't actually know. So ls prints the current directory, right? Yeah. So if it's oh, I should have duplicated this line. If it's ls followed by nothing at all, yeah, let's keep it like this. So that's the ls command. There we go. We should be able to parse that as well. Maybe I'm going to pull these things into my tests because we're gonna be here a while. Is cd efg, right? Yeah, that works. And for ls, we are going to do the same thing. ls is just ls. Yes, no arguments. Let's load our latest code into the REPL. And that should parse as the ls command. Yeah, cool. Now let's parse the output. Do we need to do something with output? Yes, we already had a record type here. Nope, a union type. So it's either a directory listing or a file listing. There, we can use the same approach. Cool. So let's grab a directory listing. This is a directory listing, so that should be a dir of e. Why is it squiggling? Let's maybe the return type is not clear here. It should be in a line, a parsed line. Oh yeah, of course. It has no this command has no relation to that command. If that makes any sense. There we go. Yeah, okay, I'm gonna keep it like this. I'm gonna keep the outer type in the outer parse, so this inner is command does not need to know about the wrapping type. There we go. So it's actually a command cd. That's not how I know. Okay, maybe with parentheses then. That's another command. And that's an output. I think if we kept it in one type, these 4 cases, that should have also worked. But I like separating my inputs from my outputs on a type level as well. So let's keep going this way. And if it's an output line, we output that parsed line. There we go. And this should return an output, and that's either a directory or a file with a size. Yeah. So if it's a directory, we have dir space. Yeah, we can get rid of the space. And then we have a directory. And otherwise it's a bit more complicated. So that's a file. And we can do some magic here. So then we do file.split. Paramatching here might not be the best thing, but okay. Split on space. Let's make the compiler happy a bit. Okay, now we can start thinking about it. So that's a very long number and a file name. But this should be enough to work for the dir command. So in theory, if everything works the way we think it does... Stuff is blowing up. What's blowing up? Do I have a... Oh yeah, I'm parsing the example. That's not for now, just yet. We can still parse commands. Yes, can we parse outputs? It looks like we can parse outputs. That's great. So now let's parse not the directories, but the files. Let's grab an example of a interesting one. This is an interesting one. So that should be a file, and that's yet another tuple containing a size. One, let's grab that. I'm not gonna type that. It's 6 o'clock in the morning. I should know better. There we go. So that should parse into that. Currently it does not because we're not doing it. We're falling out of the pattern match. We have size, we have file name, and we have whatever. Is that not how it works? Oh, it's an array. Yeah, I'm just gonna destructure using this syntax then. So we have size and file name. And so we can return no. Why is it complaining? Oh yeah, we need to return it as an option. Now let's keep using the parentheses. We started with parentheses, we'll end with parentheses. There we go. This rule will never be matched. Oh yeah. I think we're good. Yes, we can parse every kind of line we receive. So let's try parsing the example now. That seems like we're parsing correctly. Ooh, I'm getting excited. This is a fun problem. Cool. Can we parse our inputs? Just to make sure that we can parse everything correctly. Yes, we can. Okay, next step. We need to build the tree. Is that the next logical step? That's the next logical step. As you can see, I'm going very naively through the solving these puzzles. I don't think too much about what I'm doing, and it's only when I hit performance problems that I start really thinking about the problem. But I think we can continue on down this route. Next step, building the directory structure. So what would that look like? That would look like going over every line we just parsed and doing something. If it's a command, if it's a change directory command, we can update our path. So I'm already thinking about a fold and having some state that contains the current directory and state that contains the tree we built. Is that a good idea? Do we need to have the actual tree? We could do a lookup table as well. Maybe that's easier, then we don't need to navigate trees while we're changing directories. Yeah, first idea, let's build a lookup table that maps a path to... Yeah, somehow we were gonna get the tree out, so I'm not sure yet. But let's play around with it. So let's keep track of some state while we're processing these lines. And I think we're going to need the current path. Let's model that as a list of strings because our directory names are strings. And tree. So our directory structure is a whatever. A map of paths to files or directories. So that's what's the thing again? What's a file or directory called? An output. Yeah, so I think that's good stuff. Maybe we'll change this tree thing to an actual tree, but I'm not sure yet. So now we can iterate over our lines and update some state. What's the first? Do we start in root? No, we start nowhere. Is the first line of my input also change directly to root? Yeah, so I'm just gonna keep our path is empty to start with, and our tree is empty to start with. And now we need this process line function I just conjured up into existence, and it takes the state first. Yeah. There we go. That's the skeleton. Ooh. There we go. State. I'm not happy with the word state. What does this represent? Nah, not gonna worry about it. If we model this as an explicit tree, we don't even need to keep track of the path. Can we go up multiple levels at once? That would make it a bit trickier. Apparently not. No, we only go up one level. Then I think a tree might actually be the better alternative. And then we don't even need to keep track of the path. Yeah, I changed my mind. I changed my mind midway. So our tree is not going to be a map, but it's going to be an actual tree. So that's either a file of file, and it's a type. That's why my compiler is not happy. Let's extract this file structure into its own thing. So file info is the size and the file name, and now we can do this and this, and probably some tests failed. Yes, because now we need to insert another level of types. There was something with anonymous. I think you can do it differently as well. No. Do I not need to specify? What have I changed? I extracted the structure. Wait, let's comment this one out. Oh, that's the actual problem. Huh? So this all compiles. And this makes it clash. Yeah, it makes it clash. I'm just gonna prefix it with a D. It's like file in a tree. Let's call it file node. Or we have a directory node. What do we need for that? Do we need the names? No, we don't even need the names. Let's just keep the subfolders or the sub artifacts, which can be files themselves or other directories. Sure, let's go with this. What's our empty tree look like? Ooh, is this the best idea? Yeah, let's keep it going. I'm not changing it. Sorry, it's this one. It's why is it saying array? Oh yeah, this is array type. This is list type. Whew, it's a harder one than yesterday. That's for sure. So okay, I think this structure might help us build the tree. Yeah, we don't have a hole to put our directory sizes in, but let's worry about that once we have our actual tree parsed. So Let's paramatch online. Do we need to do something with the ls command? I think we can skip the ls command, but I'm thinking ahead too much already. So if it's a command and it's a cd command, do we go up or down one level always with cd? Are there slashes in here? That's maybe the... Next to root, there are no slashes in here, so we can always go... Assume that a cd goes up one level or goes down one level. So if it's up one level, we do something, and if it's down one level, we just go down one level. What does that mean? cd dir. What does that mean for our... We need to know the current node. We still need to know the current node. Yes, or we need to model this as a zipper data structure, or we need to know the current node. I am contemplating again of I'm rethinking my... Should this be an actual tree structure as of now? You know what? No, I'm again changing my mind, and I'm going for the lookup table. I'm sorry, Dirtree. Maybe we'll need you in a second, but yeah, changed my mind yet again. So we have a current directory, current path, and we have our lookup table of mapping the current path to a list of... What is it called again? A list of outputs. Output is a weird name in this context, but... I'm calling it tree, and it's not a tree, so... I'm going to regret this later, but yeah, okay. And current path is empty, and the tree is the empty lookup table. We've been here before, but now I think we're gonna stay here. Okay, back to where we were. Okay, now it makes more sense in my head. The other step was too big of a step for my 6 o'clock in the morning brain. If we have cd dot, we need to go up a level, sorry. So that's state with current path without the last step in the path. And if we have a new directory, we go down a level. So we append dir to the current path. What? Do I have my... Yes, I have my actual running in there. Okay, so let's see this work. Let's call this initial state, so we can reference it multiple times. So if we do a here, if we do a process line on the initial state, and our line is a CD ABC, we should have that in the path. Yeah, that seems to work. So let's play around with it a bit more to convince ourselves that it's really working. So that's a single command. Let's put that in a list so we can fold. And let's do that 2 times in a row. Oh, come on. Okay. DEF should also work. Yes, and if we pop with this one, we should be able to pop. Good enough. Yeah, good enough. I was contemplating this dot dot is actually a special CD. It's like go up CD. It's not the same as the other ones. Should we encode that in a type? Hell no. We've been working for 40 minutes and part 1 still is not done. So no, we will not be encoding that in a type. I think this is good enough for the change directory. So now we are keeping track of the current path. That's something. The other commands, ls, now that I think about it, we don't really care. We just need the output from the ls command. So why did we even parse it? So if it's output, and if it's a file, does it matter what it is? If it's a file, it's a file. If it's a directory, it's a directory, right? Yeah, I think we just need to keep track of the output. I'm assuming that's a yes. Yeah. So when we have an output command, we don't change the current path. We keep it as is, but we change our tree. And we add an entry to our lookup table. What's the entry? Our current path. And no, it's actually not correct, is it? We need to not add, we need to add or update. So yeah, we're gonna write a function for that. Let's call that insert into state.tree. And what do we need to insert? The output. And where do we need to insert it? In state.currentPath. So yeah, let's write a helper function for that. And if we encounter anything else, we just ignore it and keep going with the state we received. Okay, so one level deeper, deal with the sub problem here. How do we insert a node into the tree? Let's first get the things we know about this level. So everything at the current path is tree map.tryfind. At the path, and let's pattern match. If there's nothing, we need to create something. So then we know node is at this path. And if we already found some things, we just append this node to these things, and this is like the updated thing in our lookup table, and then we can just say tree map.add. Is that an add or override? If a binding with a given key already exists, the existing binding is replaced. So that's exactly what we need. Okay, in my head this was what we need, but there's something wrong. What's wrong? It's expected to have a string list output list, but here is type. That is not correct. What is the signature or insert function? Tree looks to be correct. But the return type looks to be crazy. What's updated? Oh yeah, you need a key and a value when you add something. Oh, that took a while. There we go. Could this be it to build our lookup table? This is not Christmas music, it's video game music, but it reminds me of Christmas for some reason. Okay, but let's see if we can parse what did we do now? An output command? So if we have an output file, we should get something. And we get that at the ABC level we have a file. That's correct, right? So maybe do something else. Let's go down a level again. And let's add a directory. DEFGHI, so that should all work and give us an updated tree. At DEF we have a new directory GHA. That looks correct. Or at least we're doing something. We're building a lookup table. A lookup table is not a tree, of course. Do we need to go through a tree, or can we call it a night? I think if we just use this lookup table or this map recursively while we're calculating sizes, we'll get there. If we just write a recursive function, we don't need to build an actual tree. We can pretend it's a tree by using recursion. Let's go with that. I think we have all the data in here now to actually start calculating. So what did the question ask of us again? Let's take a look. Total size of each directory. So we need to figure out all the directories, and we need to figure out all the directories with a total size of at most 100. A tree will be handy because then we won't have to calculate directory sizes 10 times. I mean, we are going to do a lot of duplicate work if we keep it as is and just go top down. Yeah, I think we're going to do a lot of double work, and we could figure something out with memoization or remembering intermediate results, or we could just build the actual tree. This might be the first day where we hit some performance problems if we don't think about this kind of stuff. We might, I'm not actually convinced. Yeah, let's think about this for a second. A naive implementation would just now use that map to figure out or loop over every directory. We have those somewhere, right? In our lines, we have all the directories. Yes, we do. So given that and our lookup table, we could figure out what every directory contains, and then we could sum. Yeah, let's try that first, and if we hit performance problems, let's not do memoization, but let's build the actual tree bottom up. So we don't have to recalculate directory sizes of like deeply nested inner directories 10 times. Yeah, let's go with that. I don't care about the state anymore. I care about the table, or the lookup table, so that's the tree. And I'm calling it tree again, but it's not a tree, so I'm sorry. My future me, I'm sorry for this. Okay, let's grab all directories. I'm gonna pattern match, or I'm gonna use the choose function to extract only the directory lines. And let's keep it in the dir case. There we go. Is this all the directories? No. Oh yeah, in other cases we need to not return anything. There we go. So this should grab all directories. A, D, and E, is that all we have in the example? D, E, yeah, looks like it. So now we can loop over all directories and figure out its size. Easy peasy, lemon squeezy. And this is where we're gonna do a lot of double work, but I don't care. I will care in a minute or 10, but I don't care right now. It's a fun little exercise. And it's so long. There we go. And this is probably going to be a recursive one, probably because we are making it harder for us. We're intentionally making it harder for us. So, how do we figure out the directory size given what we have here? Is it easy? Can we easily figure out what are subfolders? Oh no, we're making it really hard. I think maybe building the tree might be might be actually an easier step for our poor early in the morning brain. If we keep it like this, say we have a directory somewhere in the middle, finding the directory itself and its descendants won't be that big of a deal. Yeah, finding a directory is easy. It's just finding the key where the directory name is the first thing. No, actually, that's okay enough. And then you have all its files. But if you hit a directory in there itself, you know, okay, let's look up what's in E. It's not that hard. It'll work. Okay, so what's at this directory? That's it. Do we need the entire path? Do we need the entire path in our keys here? Or just the directory name? Can you have clashes? I mean, can you have directory names? On different levels that have the same name? Doesn't appear to be the case here. But is that a dangerous assumption? That's probably a super dangerous assumption. Or no, they look pretty random to me. I'm gonna make that assumption that every directory on our file system has a unique name. That makes it a bit easier. Makes it pretty dangerous as well, but makes it pretty bit easier. Can we verify that? We can verify that. Let's quickly verify that. Before shooting ourselves in the foot, let's make sure that the assumption holds. I think this is enough, right? Of course it has to hold, because we are... I'm internally convincing myself, but it's not working. No, I think if we grab this, like our tree, and look at all the keys in there, yeah, that will let us check our assumption. Oh, printed out already. I want to see all the keys in there. There we go. Uh-oh. Uh-oh. I can see duplicate folder names in there straight away. Or we have a bug, or our assumption is invalid. Let's take a look at HFM. HFM is inside of GZD. No, that's not how I'm supposed to interpret this. HFM is in GZBIM. Okay. This is actually pretty hard to figure out with a large example like this. Let's not make the assumption if we can't validate it. Let's not. So, if that's not okay, then what do we do? We don't do this, that's for sure. We don't grab the directories like this. Yeah, let's not grab directories, let's grab paths. So those are all the directories, or all the, yeah, those are all the directory locations we need to take a look at. Root, A subfolder, D subfolder, and E subfolder. That is a subfolder of A itself. Does that match with what we're seeing here? A, E, and D. Yeah, looks correct. Okay, still feeling up to it. We're an hour in the stream. Yes, still feeling up to it. That's always going to be in there, yes. So at path, we have something. And what's in there? What does our tree look like again? It's a list of outputs. Yeah, okay. If it's a file, it's easy. But if it's a directory, we can recurse, right? Yeah, cool. Let's go with that. So we have add path. And this is where our doing a lot of duplicate work will really hurt. Let's inline it because it's going to be a recursive function, and I don't feel like doing mutual recursion just yet. No, let's do it. And this also needs the tree, but yeah, this also needs a tree. There we go. So I'm defining two functions, calculate size and size of. And they are recursive, so they can call themselves, but they can call each other. They can call one another. That's why there's this AND keyword. And it's because calculate size will call size of, but if we hit a directory in the size of function, we need to recursively calculate that size. And that's why I'm dropping to this weird rec and construct here. It'll make sense when we see what's happening. So size of the output. If we hit a file, it's easy. And if we hit a dir, we calculate the size of path, but path is a path and not a directory name, so we need to figure that out. That's next. So this is a bug. That's a top level thing. That's not a full path, so we need to build a path or find a path. There we go. How do we... There's a bug in there or something that doesn't compile, but it's one step at a time. How do we find a path given a directory? It's the first key where the final slash or the final thing is the given directory name, I think. These are big steps. We are seeing zero feedback from tests or playing around in REPL. Bad idea. But yeah, I think this is good enough to calculate. There are no more red squigglies, so at least our types line up. And we even have an answer. Let's see what this looks like. We have a size for root, we have a size for A, D, and E. And E has 584, sorry. 584, yeah. D has something in the 249 range, yes. And root has 483165. That is correct. I'm curious about the performance because we already know we have a performance issue for large directories. Let's see whether or not we have a large directory. I'm wrapping everything in a function and I'm running it on the example one more time. We're crossing 100 lines of code, so it's a spicy one today. But yeah, so we have all our directory sizes, and then we need at most this much. I'm gonna keep it at this. I'm gonna rename solve to... No, I'm not gonna rename anything. Let sizes equals this thing, and then we're going to filter those sizes. Don't care about the path, we do care about the size. Size has to be bigger or equal. Does that matter? At most, no. It has to be... That's the maximum. It has to be smaller. Or equal? What does at most mean in English? Inclusive? Yeah, let's keep it inclusive. Okay, so this gives us a sublist of A and D. In this example, the process can count files more than once. Yes, when E is a subfolder of A, it happens. Cool. And that's it. We need to grab the sizes, and then we can sum them. So we can do a sum by second part of the tuple, and that should give us the example or the solution. 95437. That is correct for the example. So let's see what this looks like for our actual input. And let's put a timer on there, because I have this inkling of a feeling that if not for part 1, for part 2 we might have a problem. We have a problem for part 1 already. We're going into a calculation loop. Oh, there's a stack trace. What happened? Did we smash our stack? I think we overflowed our stack, which was actually to be expected. This is not a... This was not some huge surprise. Good exercise. Good exercise. I'm loving it. Nice little puzzle. Let's see that crash one more time before we fix it. There we go. Nice big stack trace. What's the actual problem? Stack overflow. A stack overflow. What does it mean? Do we have an infinite loop? I'm curious what we're actually doing when the stack overflows. Let's see. Let's print out calculate size. Let's see what we're doing here. It doesn't smell like the problem I was anticipating. I think we might have an actual bug in here. Some kind of infinity thing. So let's see it crash. Let's see it crash. Or let's see it print out what it's doing while it's crashing. Printing makes it go even slower. That's to be expected. Is it just me or am I seeing a lot of duplicate? Stop. Stop. Okay, stop now. You can really stop now. There we go. Let's grab the output and let's take a quick look at it. What are we seeing? I am seeing this infinite loop. No? Calculating the size of this, and then it's calculating the size of this again, and it's calculating the size of this again. How is that happening? So calculating the size of root, that makes sense. Let's print out all the paths we have. So I don't really use the debugger that often, I just print stuff. Or no, when I write code on the job in C#, I do use the debugger sometimes. But for F#, I have little experience with debugging. These are the paths. Let's take a look what's happening here. Maybe I should have sorted them. Let's sort them. There we go. Let's load everything in the REPL again, and let's try that one more time. Just because it's a lot of fun to see computers crash. Oh, I don't know what I did. There we go. What's happening? Are there any duplicates in here? Can be, it's a map. These are the keys of a map. Yeah, I don't think there's a problem in the paths. This looks correct. Okay, I'm gonna cheat. I'm gonna apply memoization. Yeah, I'm gonna cheat. And we're gonna remember the intermediate values. If we calculate the size for a directory, we're gonna store that somewhere and not have it recalculated every time we hit its parents. So we don't have to recalculate the entire tree. And I'm gonna break my own rule. I have a rule I prefer to use, and it's don't use mutable state, but for memoization you can do it without, but it's easier if you use a mutable dictionary or something like that. So let's look up F# memoization. Is there no somewhat official way? Not that there needs to be an official way. Let's take a look. I'm looking at a dictionary. Yeah, I'm just gonna know what? I'm gonna make a global variable. I'm gonna make it even better. So when we calculate sizes, let's make a where is the dictionary collections? No? Where is the dictionary? What's dict actually? What does F# dict mean? I've not seen that before. There we go. That's not what we're looking for. We're looking for dict keywords. Hello. Is dict not a thing? Why is my autocomplete giving dict? Oh, it's the variable I declared myself. I'm sorry. That was a... Yeah. Where is the dictionary in C# located? That's not the docs. I'm looking for system collection.generic. Okay. I'm not sure if writer helps with F# programming, but Visual Studio is... If I do this, for example, in C#, my IDE can help me. It says like, okay, you can find dictionary here. I've not seen that for my F# code, or at least not when I do interrupty stuff like this. Does that work? Can I use the F# list type in the dictionary? Looks like it. How do you access a dictionary again? I never do this in F#. I'm super lost. Let's go at the example again. Yeah, sure. Let's just grab this thing. So an example value is this. If we get that value and we find a head, we return it from the dictionary. Otherwise, we calculate it. That's our calculate size thing. And we add it to the dictionary. So now we need to incorporate this thing into our calculate size thing. Yes, I think so. So we have our global mutable state, the memoized thing, or the dictionary that lists paths to their sizes once we have them. So here we have the path we need to... Yeah, here we have the path we need to calculate for a directory. Is that the first and only place in our code where we need to do this thing? I think so. So let's try to figure out whether or not we calculated the size of this path already. And if it's true, we have the size. Yeah, and if we don't have anything, we can calculate the size. And that's this thing we're doing here. And we add path, the size, and also return the size. So this has been a very painful introduction to memoization. But I think we're there. Let's see if this works a bit faster. Let's see if it still works for the example. That's a good first thing. And since we have mutable state now, there's a global dict somewhere in there. We have to be a bit more careful when running things in the REPL. Maybe we can do dict.clear somewhere to make sure we don't accidentally reuse. Yeah, where do we actually calculate sizes? Over here. So let's clear our dict over there. So I think we don't have to make it global. We can encapsulate it into like a nice calculate size wrapper function, and that would be a bit better. But let's not get ahead of ourselves. Let's first figure out whether memoization solves our performance problem. Let's get rid of our print statements. We had another one somewhere. There we go. Is that the correct answer for the example? It is, right? Yeah. Let's encode that. Might have encoded that before messing about with memoization, but there we go. Let's try that again for our input. If this works, I will be a happy camper. No, we're still overflowing. Interesting. My spider sense was telling me that memoization was not a problem of this stack trace. I was looking at, or we were seeing the same path occur again and again and again, and that does not make sense. So let's print out the path yet again and see what's happening. And let's print our cache hits. This O is confusing me, so let's call that what it is. Yeah, everything looks correct. So let's see what's happening behind the scenes. We have a lot of cache hits, so that's a good thing. Doesn't look like we have a problem with a why is there a stack trace in there? Let's try that again. So reset our session, load everything into the REPL again one last time. I really hope we figure out the problem in the next 6 minutes, or I'm calling it time for a break. There we go. There we go. Let's take a quick look. So we're calculating some sizes. And here we have a first cache hit that all looks correct. Yeah, that's also a new directory. Yes, we already calculated the size of this directory here, so there's a cache hit. So let's maybe try to detect the pattern first. See a lot of Z HFM. I see a lot of this thing. What's happening here? Why is it calculating the size of HFM and then cache hitting? Oh no! Oh no! Yes, of course. Okay, what we're seeing here, we're seeing that we're calculating the size of HFM 3 times in a row. And we're cache hitting for all the subdirectories, but we're not cache hitting for this directory itself. So we built in memorization, yay us, but we didn't build it in at the correct level. Boo us. Or great learning moments us. So let's take a look. We're doing it on the size of thing, but it would be better around the calculate size thing. So. So, let's put it here. And we need to call size of the thing. Ooh, I'm confusing myself. What have I just done? This is the thing we need to do if we don't have a cache hit. There we go. There we go. And we can get rid of the memorization part here. And this will be memorized automatically. There we go. So what did we do now? We moved memorization from the size of function to the actual first function we hit, which is calculate size. So I did very big steps for my tired brain. Let's see if this all still makes sense. So now we have a calculate size function that as a first thing tries to look up the value for this path in our lookup table. If we have a hit, we return that pre-calculated value. If we don't have a hit, we find nodes at path. This is already confusing me, so I'm gonna rename that. And we calculate the size of every node recursively. I'm not happy about this, because this will actually do the calculation. And this will be recursive. Now I think it's fine. This mutual recursion thing and the memorization thing, I've never seen those two work together, which is why we ended up where we ended up. I'm not even sure whether or not it's correct now, because this is where we memorize. And if we don't have a hit, we go boom, 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 we do everything, and we call this list.sumby thing. And that will calculate sizes of subtrees. This is just reading out, but it's doing some work. It's building paths. Yeah, I'm not sure if we needed to rip out memorization in this size of thing. If it's still slow, we'll reintroduce it. I am sorry. Oh, I need to include my unquote, my libraries. Yeah, that still works. That still works. That still blows up. Yeah, that still blows up. So I just convinced myself. let's reintroduce. So we have mutual recursive functions, and we have two places that do memoization. Does not sound like the cleanest of designs at all, but if it works, I'm willing to at least take a little break before continuing, because we've been going at it for 90 minutes already, and it's fun, but it's tiring. And I need my workday starts in an hour, so I need a short break before I dive into or work I get paid to do. Interesting. How can I get item with the same key has already been added when I'm memoizing? Is it because of the mutually recursive thing? See, we're calculating the size of this thing. We look up the size of that thing. Oh yeah, oh yeah. This dict add will already have happened by the size of. Yeah, I've convinced myself that we don't need to add it here, probably. That's a very strong conviction right there. Yeah, still works. We're printing a lot, and we're still doing it. I give up. No, I don't give up, I pause. Maybe let's try one more thing. Instead of giving up there, let's give up there. This is my final Hail Mary. This day 7, it's day 7, yeah. Day 7 deserves a redo or a more elegant approach than what's happening here. It definitely deserves an elegant approach, but I would be happy right now with a working approach. It's not in the cards for this morning, so I'm gonna take a break, have a think on it, and tonight or in a couple of hours I'll resume the process or the struggle, because it's a bit of a struggle, but it's fun. I'm having fun, and I hope you did too. So see you in a couple of hours. Thanks for watching. Bye bye.